Hey guys, welcome to the level 2 algebra paper from 2022. If you're joining us for the first time, the way this video works is that I go through each one of these questions step by step, tell you guys what you need to do for achieved merit and excellence. The best way to watch this video is to pause the video at the start of each question, try the question out by yourself, and then unpause the video just to see how I go about getting to the answer. So, without further ado, let's get started. Alright guys, so the first question we have here is nice easy one to start the paper with. So what we've got to do is we've got to get rid of the 3 to the other side, which means it's going to become plus 3. Then what I'm going to do is I'm going to get rid of the x plus 4 to the other side as well. So I'm going to get 2x minus 3 equals 3 times x plus 4. At this point, I need to make sure I expand the two brackets. And what I end up with is 2x minus 3 is equal to 3x plus 12. And then it's just a matter of rearranging. So I've got 2x minus 3x equals 12 plus 3. So what we end up with is negative x is equal to 15, or we can just say x is equal to minus 15. This question is worth an achieved, and you got to get the correct solution to actually get an achieved. Alright, moving on to the second question. What we've got here is a factorized question. So what you guys could do is you could actually replace the y, the root y as y to the power of half. So remember that root of y could be written as y to the power of half, or if you prefer to work with decimal points, you could actually have it at 0.5 as well. So when we look at this, we've got 6x cubed y minus 15x squared y to the power of 0.5. So I'm going to put that as 0.5 for now. So you got to try and get rid of, you want to simplify it to the full extent, right? So the first thing I'd probably get rid of is the numbers. So I got 6 and 15. So so I know that 3 is a common factor. So I'm going to do this step by step, guys. I mean, if you want, you can do it, fully right to the end of the answer straight away, just to show people how I go about getting this answer. So first off, I'm going to take out 3 as a common factor. So when I take out 3 as a common factor, 6 divided by 3, that's 2x cubed y, minus 15 divided by 3 is going to be 5x squared y to the power of 0.5. The next thing I'm going to look at is the x. I've got x cubed and x squared. So I'm actually going to take out x squared as a common factor. And when I take out x squared as a common factor, what I'm going to get is 2xy minus 5y to the power of 0.5. So you could kind of do it two ways. And I'm surprised that they haven't actually given one of the answers that I would have liked, which is y to the power of. So I mean, I would have done it like this. I would have gone 3x squared, and I would have actually taken out y to the power of 0.5 as a common factor, which means you're going to end up with 2x y to the power of 0.5 minus 5. And of course, if you want to simplify, like, you can write this in a different way. You could have written it like this: 3x squared over root x, root y, 2x root y minus 5. So I'm going to show you guys the answers itself, right? Like, if you look at the answers, they've actually got like a couple of different variations. So they accept this. Oh no, my answer is right there. There we go. That's the root of y. So that's y to the power of 0.5. So yeah, so you can actually do it this way as well. Ultimately, this question is worth a merit. As you can see, when you factorize it without the y, you can actually get an achieved, and then when you do it completely to the end, you will get a merit. So if we think about us, so up to this line is actually worth an achieved, and then up to this line is what it's going to get you a merit there. All right, so let's go on to the next question. Okay, so when we see this type of question, the first thing you got to realize is that you got to factorize the top, you got to factorize the denominator, and cancel out the common factors. Now I'm gonna be honest, guys, like usually I kind of do this with the graphics calculator and just kind of move on real quickly, but this time I'm gonna do it both ways, so just so people that don't have graphics calculator can kind of have a look at how to do this as well. So I'm gonna do the long method first, just because just make it a bit easier. All right, so I want to factorize the top there first, right? So I've got 6x squared minus x minus 12, and I don't know if you guys remember this from last year. You kind of do this little algorithm thing where you go 6 times minus 12 is negative 72, and you look for like two numbers that multiply to negative 72 and add up to negative 1. So in this case, we're going to get minus 9 and 8. So basically, I've got 6x squared minus 9x plus 8x minus 12. Basically, I'm just grabbing that minus 9 and 8 and throwing it in there. But obviously, you guys can't see the color. It's always nice when you pick like, what about a darker one? Can you see that? Yes, you can see that. There we go. So that's where the minus 9 and 8 end up being. Then I have to kind of split this up and factorize. So I've actually got, what do I got? I got 3x, which is going to be 2x minus 3. And then here I've got 2x minus 3. So basically this factorized to 3x plus 4 multiplied by 2x minus 3. And the reason being that, if you remember, I've got 2x minus 3 as a common factor. 3x comes from there, and the 4 drops over there. All right, so basically what I've done is I've factorized the numerator, and I'm going to write that as 3x plus 4 and 2x minus 3. Okay, got to repeat the process again with the next one, which is 3x squared minus 5x minus 12. So multiply these two numbers. I've got negative 36. So I'm literally looking for two numbers that multiply to negative 36 and also add up to minus 5, actually. Sorry, I was looking at the other number there. 9. Yeah, so we've got 9 and something. Yeah, we can actually go negative 9 and positive 4. So I could rewrite this as 3x squared. I'm just going to write it in this color this time so you guys can see what's happening. Minus 9x plus 4x, and I've got minus 12. Now, again, I've got to factorize by those two parts, so the left-hand side of the green line and the right-hand side. So I've got 3x, x minus 3. And then here I've got 4x minus 3. And once again, I've got two common factors. I've got x minus 3 as a common factor. And in the bracket, I've got 3x plus 4. Now that's, once again, 3x is from there and 4 is from there. So I write this up. I've got x minus 3, 3x plus 4. And as you can see, I've got two factors that are the same. Get rid of it, and I'm left with 2x minus 3 over x minus 3. So this is pretty much an extremely long way to do an achieved question. You're right, it is only worth an achieved question. I know a couple of years back this used to be like a merit question, but like now they dropped it to an achieved, partially because I think because people have graphics calculators, and it's just really fast to do this. And I'm going to show you guys how to do this in the graphics calculator real fast, right? So what do we have here? The first thing is this. When you want to factorize that quadratic in the numerator, what you can do is you can go into, where is that mode? Go into equation mode. I'm rusty here. Go into polynomial, F2, degree 2. And you literally just chuck in the coefficients of A, B, and C. So I'm going to put in 6, minus 1, and minus 12. Now, here's the thing though. The answers are coming out as a decimal point. As you guys can see it, these are decimal points here, right? But have a look here. It actually gives you the fraction format. And if you look at the answer below it, it's actually -4/3. Now watch this little trick, and most of the time it works. On the odd occasion it doesn't work, but you just have to check the coefficients to see if it works. So what do I mean by that? So this is the problem here, right? So let me take this 6x squared minus x minus 12, and I've basically found out two solutions. My first solution is x equals to 3/2, and my second solution is x equals to -4/3. Right, now those are my two solutions. Remember that when you want to find a solution for a quadratic, what you do is you solve it, put it equal to 0, and you rearrange. Well, we're going to flip it. We're going to do it the other way around. So in this case, instead of writing this as x minus 3/2, I'm going to bring the 2 across. So this will become 2x equals to 3, and then 2x minus 3 is equal to 0. And if you look at this side, I've got 3x equals -4, and 3x plus 4 equals to 0. And what you guys should see right now is that I've actually factorized it right there. All right, so that's pretty much, I mean, how you kind of do it. Now, if I want to show you guys the second version of it, second one, so I've got 3x squared minus 5x minus 12. So what I'm going to do is I'm going to go into the calculator, and I'm going to punch in those numbers again. So 3 minus 5 minus 12. There you go. There's my two answers there. I've got x equals to 3 or x equals to -4/3. So I'm going to write that down. X equals to 3. X equals to -4/3. Now watch this. So straight away I can put this as x minus 3 equals to 0. And the other one is going to be 3x equals -4. And 3x plus 4 is equal to 0. And once again, you guys can see that these two factors here are what we found in the previous case. So there's nothing wrong with you guys doing the graphics calculator method. I mean, it's just a bit of a shortcut there. But on the odd occasion, it will not work out. And the and the way you know that it is going to work out is have a look at the coefficients. So you got 3x and 2x. When you multiply it, you're going to get 6x squared. All right, that means that's good. That kind of works out. And if it doesn't, well, when you get to level 3, we'll talk about that, because there are a couple of tricks you can do with it. Bit of a long-winded explanation for an achieved question, but it is what it is, right? For achieved question. So this question, you know, you have to pause. You have to pause and read through it, because there's just so much information actually available here. But anyway, look, hope you had the chance to pause, but I'm just going to jump in straight to the answer. Okay, so what they're asking in this question is they're saying that no matter where this 4x4 square is, the sum of the orange must be the same as the sum of the blue corners. Now, what I'm going to do is this. I'm going to actually work on in this this second second colorful looking rectangle on the right side. So to start off, all right, we've got that first orange square, which is A. So if you look at the next one, it's going to be A plus 1, then A plus 2, then A plus 3. All right, hopefully that kind of made sense, because if you think about it, like look at the numbers at the top there, you know, if this was 18, this is going to be 19, 20, and 21. All right, so all I'm doing is I'm just adding 1 to each one of those letters. Now, if you look at the number below 18, so that's 25. That's like A plus 7, because it's actually going up by 7 every time. So here I could actually write this as a plus 7, a plus 14, and then finally what I have, the blue, is a plus 21, because if you think about it, it's actually 3 weeks, 21 days, or 21 numbers. It's gone up. Now if blue is a plus 21, the number right next to it is going to be a plus 22, a plus 23, and a plus 24. Okay, I think that's this is probably the most trickiest part of it, right? Because after that it's a straightforward equation, because it's asking for sum of orange colors. So orange, so my two orange squares is a plus 24, because how am I going to mark it? Like, let's do this like this. So this is my a right there, and then I've got a plus 24, which is here. Those are my two orange squares. They add up together, and what do I get? I actually get 2a plus 24. Now let's do the blue one. So with the blue, I've got a plus 3 plus a plus 21. How do I do that? Well, a plus 3 is this blue here, and a plus 21 is this blue here. So when I add those two up, I get 2a plus 24. So, well, we've proved it. Therefore, orange is equal to blue. All right. So, grades-wise for this question, we are looking at correct algebraic evidence, but no conclusion. Conclusion explicitly drawn. Oh, see, that's just being picky, isn't it? I mean, have a look at the answers, you guys. So they've got the 2a plus 24 and 2a plus 24, right? They've done all of that. Therefore, sum of orange equals sum of blue. Guys, now that's what I wrote, but I didn't write that no matter where you start the square. Now, if I look at the answer schedule for merit, two sums compared and conclusion explicitly drawn. If I go back to my working, and it says 2a, well, maybe I should put like this one little statement above it, something like 2a plus 24 equals to 2a plus 24. Therefore, orange equals to blue. And I think that should qualify for a merit. And of course, correct algebraic evidence. So I don't know if it's like both the things they want or just one of them. I'd probably think both, because it says correct algebraic evidence but no conclusion. So you do have to write that conclusion to get a merit. All right, so the second part of this question, can't believe I put that much gap for it. Cool. So for the second part of the question, what we've got is pretty much the same idea, but she's wondering about the products. Could they be the same, right? Now we already know these numbers here. So we've got a plus 3, and that one's a plus 21, and this one is a plus 24. So all we're really doing in this question is just working out the products of those two numbers. So if you look at product of orange, that's going to be a multiplied by a plus 24. And on this side, I'm going to do product of blue. So product of blue is going to be a plus 21 multiplied by a plus 3. It's, you know, in hindsight, I remember last year, like a lot of guys were saying like, oh, the calendar question was horrible. But to be honest, it's actually not too bad at all, because all you're doing in this is expanding the brackets. You got a squared plus 24a on one side. On the other side, you've got a squared plus 3a plus 21a plus 63. So you're going to end up with a squared plus 24a plus 63. And what is she saying? It's not possible where the opposite corners are the same. So we're actually going to put both of these together. All right, so what we're going to do is a squared plus 4a equals a squared plus 4a plus 63. I'm trying to figure out, is orange equal to blue? And as you guys can see here, there's a squared on both sides. I can cancel them out. There is 4a on both sides. I can cancel them out. And what I end up with is 0 equals to 63, which is impossible. 0 equals 0 equals to 63 states that this is impossible. So in other words, what we've really done here is we've actually proven that this can't be equal to each other. Grades wise, funny odd question. No achieved for this question. Straight up to algebraic evidence up to line double star gives you a merit. So up to this line here is going to get you a merit. Correct and complete algebraic reasoning will get you an excellence. So that last part there, just getting up to that part, actually gets you an excellence. Right, so we go to the next question. And still continuing on with the theme here. Alright guys, hopefully you had a chance to kind of read through this question. Now what I'm going to do is I am going to actually mess around with this, because I've trying to understand what the question's actually asking, but like trying to explain it is a completely different story. So I'm going to go back to what I originally know. In my original one, I know that this is a plus 3. This one was a plus 21. And this was a plus 24. All right, that's all I knew. Now, the question's basically saying what happens if this rectangle is not, like right now, this rectangle here that we have is a 4x4 rectangle, right? So it's a 4x4 rectangle. So if this is M and this is N, how would it look like? I think that's the whole point, right? Like, so what if let's kind of make this into another one. So let's say we go with a 3x3, because that's actually quite easy. All right, so if M is a 3x3, then this is going to be A, and this is going to be A plus 2. This is going to be A plus 14, because remember that it's actually going up by 7, and this one is going to be A plus 16. But the question's asking is how would we try to prove this for an M and N, right? So we kind of need to write an equation without A's, but including M and N. And I guess you got to kind of have a look at the pattern of what's happening here. So what if I do a 5-1? Let's do a 5-1, right? I'm gonna kind of do it up here. There we go. 1, 2, 3, 4, 5. So we're gonna have that is gonna be A plus 1 plus 2 plus 3 plus 4. So it's gonna be A plus 4. This is gonna be 7, 14, 21, 28. That's 28, 29, 30, 31, 32. All right. So we kind of need to write this in some sort of equation, right? And I guess this is kind of like the annoying part, because you have to come up with the equation. And it's weird because like as a math teacher, I can kind of see what's happening here, but then trying to explain it is like, that's interesting. So, but I'm going to try. Yeah, I'm going to try my best here in a way where it can kind of all make sense. Now, the one thing I do know is that this grid that I'm working with, the 5x5 grid, so if I put that as M and N, 5x5. So what's the first thing that I can have a look at, right? So if I was to go, eventually I'm going to go make this big grid. All right, I don't know what it is, but it's like, let's say whatever that grid is. But it actually has that m is actually the number of columns, and n is number of rows. So if I look at the first one, regardless of how big this rectangle is, the first orange one is always going to be A, right? So hopefully that kind of makes sense. Now, this last one on that line is going to be A plus m minus 1. Now think about it. The reason I say that is because let's go back to the 2x2 grid. So notice how m is 3 here, and we're actually getting A as plus 2. Notice how m is 4, we're getting, oh, that's that shouldn't have used that color. So you can kind of see that it's plus 3. Or when m is 5, this part here is actually 4. So when we say the letter m, we could actually say that that last part there is going to be always 1 less than that. All right, that is the blue corner. Now if you look at the bottom blue corner, it's actually increasing by 7 lots of n, but again it's like it's reducing by 1, right? So if you think about it, like look at this here. I'm gonna have to do this in a different color, but like hopefully it kind of makes sense. So when n is 3, we're actually doing A plus 7 times 3 minus 1, because it's always like 1 extra. Like if it has 2 rows, you're increasing by one of them, so 1 7, right? So if you were to expand this, we're going to get A plus 7 times 2, which actually gives A plus 14, and the same thing here. So if you look at here, we're going to get A plus 7 times 4 minus 1, which is at 21, and here we're going to get A plus 7 times 5 minus 1. So if I go to this corner here, I'm going to get A plus 7 times n minus 1. And if that's the case, then the last square is going to be A plus 7 n minus 1 plus the m minus 1, because the m minus 1 is like literally how many times it's going across the right hand side. Now I mean like I said to you guys before, it's like some of these questions is like I can see it happening in my head, but trying to communicate that to you guys, it's actually quite tricky, but I'm hoping that I actually made sense with that, because this is literally the trickiest part of this question, because the next part of the question is just like a simple expanding and showing that they're both equal to each other. Because have a look at this. There's my 2 orange things. That's my 2 blue squares. So if I was to combine them, so for orange, I've got A plus 7 n minus 1 plus m minus 1. I really hope that I actually pulled it off correctly. Let's see, 7n minus 8. And then blue here is going to be A plus m minus 1 plus A plus 7n minus 1. And you can kind of see it. I mean, already the orange and blue looks pretty much the same. I mean, if you want to simplify it, you can. You're going to get 2A plus 7n minus 7 plus m minus 1. So 2A plus 7n plus m minus 8. And I think I'm getting the same thing here. 2A plus m minus 1 plus 7n minus 7. And 2A plus 7n plus m minus 8. And we can say both expressions are equal. Yeah, so totals are always equal. So as I said to you guys, I mean, it's a super annoying question because it's it just takes a while to understand how to actually generalize it, just because like you've got so many different kind of things happening. And I always say this, right? Like any one of these investigative questions, take your time. Oh, geez, well, I don't know, if you're not doing, if you're doing only like 2 papers in the end of your exams, you got like 1 extra hour. But if you are doing stats and calculus, probability and calculus, then yeah, you're in a bit of a time crunch there. But literally, guys, that is a very long-winded explanation to get an excellence. Reasoning valid, but n used for the corners, correct algebraic evidence, but no conclusion. So, I mean, I'll show you guys the answers. So the answers kind of puts it up there, but then in here, correct algebraic evidence, but no conclusion. I'm thinking somewhere along here or here, you could end up getting a merit, but I'm really not sure. What do they mean by correct algebraic evidence? Do they want right to the end, or do they just want one of them? Not sure at all. But anyway, that's question 1 for us. All right, guys, so we're off to question 2 here. And it's interesting, I kind of was talking about this example in question 1C about how when you have 2 solutions, you kind of work backwards. Well, we're literally going to do that in this case. So if you kind of skip through that part and trying to figure out what I'm doing, you can actually go back there, but otherwise you can also watch it here as well. So you've got x equals to 1 over 3 as one solution, and my second solution is x equals to negative 2 over 7. What I'm going to do is I'm going to bring the 3 across and make this 3x is equal to 1, and then 3x minus 1 is equal to 0. Step 1. Step 2, on the other side, I've got 7x is equal to minus 2, and then 7x plus 2 equals to 0. So what I've actually done is I've actually worked backwards and come up to my 2 factors, which happen to be 3x minus 1 and 7x plus 2. So at this point, I just need to expand the brackets. 3x and 7x, 21x squared, plus 6x minus 7x minus 2 simplifies to 21x squared minus x minus 2. Now, in this particular paper, at the bottom of this question, they actually put that a equals b equals c equals. So I think it's important that you actually write down what a, b, and c is. So I'd actually put down 21, negative 1, and negative 2. So do not leave your answer like that. Make sure you kind of put in those a, b, and c values. All right, this question here is worth and achieved, and we move on. So next question, one of my favorites, find the discriminant. All right, so we've got a is equal to 2, b equals to minus 12, and c is equal to 7. So discriminant is b squared minus 4ac. So we've got negative 12 squared minus 4 times 2 times 7. Whatever that is. I think I need to work it out on the calculator. Just being lazy. What do you got? 144, take away 56, 88. So discriminant of 88, correct discriminant of 88 gets you an achieved. Now, weirdly enough, this question is actually a 2-part question. You can get a merit for that next part, and just it counts as 1 merit grade, which is which is a bit strange, but like anyway. So all it is we've got that equation y equals 2x squared minus 12x plus k. Find k while the equation y equals 0 have exactly 1 solution. All right, so for part B, we know that if it's 1 solution, then we're gonna get b squared minus 4ac is equal to 0. So that's what it means for 1 solution. So we've got negative 12 squared minus 4 times 2 times k equals to 0. So what we've got here is 144 minus 8k is equal to 0. And then we've got negative 8k is equal to negative 144. And our k value is going to be negative 144 divided by 8. Therefore, k is equal to 18. Substitution made line 1 could get you an achieved. I guess this is getting you an achieved for substitution in line 1. Correct value of K gets you a merit. Nice, good speed for this question. All right, question C. So what we've got a square root that we need to get rid of. So what we're going to do is we are going to get rid of the square root by squaring both sides. All right, and remember that square, especially for the 3x, a lot of people make that mistake where they go 3x squared as 3x squared, but it's actually 9x squared. Remember that. All right, so here we've taken square root and squared, they disappear, and what we've got is 2x plus 3 equals 9x squared. So rearranging it, we're going to get 0 is equal to 9x squared minus 2x minus 3. And at this point, it's actually asking us to solve. You know, graphics calculator is probably the way to go in this case. What do we got? F2 polynomial, 2 degrees. Of course, you're not going to recognize that. We've got 9 minus 2 minus 3, and there is my two answers. All right, so I've got x is equal to 0.699, or I could actually have negative 0.476. Now, if you don't have a graphics calculator, you will have to use the quadratic formula. So you've got x equals to minus b plus or minus b squared minus 4ac over 2a. And you've got a is equal to 9, b equals minus 2, c equals to minus 3. So x is equal to negative 2 plus or minus b squared, which is negative 2 squared, minus 4 times 9 times c, negative 3, over 2 times 9. Now guys, I'm not going to actually work all of this out. Just keeping in mind the time, really, that's all. But yeah, feel free to kind of work that out, and you should end up with those two answers there. Yeah, so this question is actually worth a merit, and you need both answers for a merit. Obtains correct quadratic gets you an achieved. So getting to this line here will actually get you an achieved. Okay, let's go to the next one. Okay, so with this question, what we've got is we've actually been given what qx and q star x is. So qx is actually right here, and q star x is right there. So it's asking us for solutions for that equation. So I'm just going to put them equal to each other. So I've got fx squared plus gx plus h equals hx squared plus gx plus f. So I'm gonna collect all my common, well, actually the first thing is I'm gonna get rid of the g of x, because g of x and g of x is on both sides, they're positive, so they disappear. And what I've got here is fx squared plus h equals hx squared plus f. Now, I'm going to bring everything to one side to see if I can get this quadratic to work. So I've got fx squared minus hx squared plus h minus f, and all of this is equal to 0. Now, I can see that x squared is a common factor, so I can take it out. And what I'm going to end up with is f minus h plus h minus f is equal to 0. And I guess this is the tricky part right here, right? Like if you look at it, you've got f minus h, and then you've got h minus f. What you really want is f minus h here. I want this to be f minus h. How do I do this? Well, I can actually take out negative 1 as a common factor. Because if I take out negative 1 as a common factor, I'm going to get negative h plus f is equal to 0. And of course, x squared, f minus h minus 1, and I can kind of rewrite this as f minus h is equal to 0. And because right now what's happening is f minus h is a common factor. So I can take out f minus h as a common factor, and I've got x squared minus 1 equals to 0. And of course, remember that the x squared comes from there, and the minus 1 comes from there. So basically, what I've got here is f minus h is equal to 0, or x squared minus 1 is equal to 0. Now we're looking for solutions. That means we want to know what x is actually equal to. So really what we've got here is x squared minus 1 is equal to 0. And because x squared minus 1 equals 0, so we can say that x squared is equal to positive 1, and then x is equal to square root of 1. But of course, remember that when you take a square root of a number, you're going to get two solutions. So you're going to get x is equal to plus or minus 1. So grades wise, correct working to obtain one solution only. I don't know, maybe I would say a merit to get one solution only. So if you actually go from here and you put this as positive 1, you're probably going to get a merit. That's what I think it is. For an excellence, it is actually saying both solutions correct. So have a look at the answers here. So correct working to obtain one solution only. So I would probably say about from there you'd probably get a merit. But it kind of sucks that if you forget that negative 1, you get dropped from an excellence to a merit. Man, that is just brutal. That is brutal. Okay, so we are going to go to the next question, guys. Kind of flying through this question number 2. Question number 1 took a long time to explain, but geez, question 2 we're just flying through. All right, next part of the question. So what's a good idea is, like, I'd actually write down q of x first. All right, so if q of x, what was it from the previous question? Was it fgh? Okay, so we've got fx squared plus g of x plus h. And as for the q star x, this is equal to hx squared plus gx plus f. Is that correct? Yes. So let's have a look at this question, right? So the first thing is that there is two roots, which is a and b for q of x, and then for q star x, it's actually multiples of a and b. We don't know what k is. Don't worry about it. The question is asking find an expression for k in terms of f, g, or h. You know, when you get a question like this, you're like, man, I don't know how to start this. And that's okay. If you don't know how to start this, like, you look at it right now, you got two quadratics, something about solutions and roots. Well, the only thing that we can logically do in this step is to actually use the quadratic formula. So that's what I'm going to do first, because what I'm going to do is I'm going to work out what these a and b potentially could be. So let's say I'm going to use the quadratic formula here. So a is equal to f, b is equal to g, and c is equal to h. So I've got x is equal to minus b plus or minus b squared minus 4ac over 2a. So remember that x is my solutions, so it could be a or b. So I've got x is equal to minus g plus or minus g squared minus 4f, c is h, divided by 2f. Now, we don't know what a is and b is, right? But what I can kind of do a little trick here is I can kind of say something like a could be minus g plus. Well, it doesn't. I don't think it matters which one you go with, whether you go with plus or minus. But like, let's actually go with plus. Let's say that a is equal to this right here, right now. All right, and then let's kind of say that b is equal to the other part, minus g squared minus 4fh over 2f. Okay, so what we've just figured out here is, I'm just going to highlight this here for now. All right, so this is what a is equal to. And there's my root of a. Sorry, one of the roots, which is a, for q of x. But the second part of it, it actually says ka for q star x, right? But what we're going to do is we're going to actually try and figure out what one of the roots is. Now, it's not a. So we're pretty much going to kind of do the whole quadratic formula here. And we're going to get like x is equal to blah, blah, blah something, and x is equal to blah, blah, blah something, right? Something's like that. But one of them is going to be equal to k times a, because that's what it says in the question. So what I'm going to do is I'm going to actually work out what one of the roots is, and then I'm going to kind of go ka equals to that, right, to kind of prove it. But let's kind of work it out. So in this case, I've got a is equal to h, b is equal to g, and c equals to f. So once again, quadratic formula, minus b plus or minus b squared minus 4ac over 2a. So I've got minus g plus or minus g squared minus 4a is h, f over 2h. And I'm hoping you guys can kind of see something happening here, but let's kind of keep going. So we can write this now where we're going to have like two roots. So we're going to have x1 and x2. All right, with x1 I'm going to have negative g plus g squared minus 4hf over 2h. And then x2 is minus g squared minus 4hf over 2h. So I've got my two roots for q star x, and I've got my two roots for q of x. But it actually says the roots are multiples of a and b, which means if I take this green highlighted root and I multiply it by k, I should get this thing here, that solution. So that's literally what the question's actually asking us. But what we're going to do, and again you're thinking it's like, wow man, that looks complicated. Well, it's not too bad. It's not too bad at all, because what we're going to do is we're going to multiply the whole lot of them. Because watch what happens, all right? So I've taken negative g plus g squared minus 4fh over 2f, and I multiplied by k, and I'm going to get negative g plus g squared minus 4hf divided by 2h. Okay, so that's all I've done here. And at this point, I'm running out of space. Maybe, hold on, let me just fix that. So at this point, what I'm going to do is I'm going to put a whole lot of brackets here. So I'm going to put this as a bracket, and this as a bracket, and these two things as a bracket. So I am going to switch this across. So I've got k equals, well, I'm not doing anything here, so it's going to be negative g plus g squared minus 4hf. Now the only change I'm going to do here, guys, is this. I'm going to rewrite this as 4fh. All right, that's all I'm doing, and that's still divided by 2h. But now, because I've got a fraction and I'm bringing it across to the other side, it will actually flip over. So I'm going to get 2f, which is, I'm going to choose a different color here. Hold on, so it can kind of make sense. So the 2f is in the denominator. When I bring it to the other side, it goes on the numerator. And this whole thing is on the numerator. So when I bring it across, it will end up in the denominator. Negative g plus square root of negative g squared minus 4fh. Now, I hope you guys can see why I kind of flipped that hf into fh, because basically this entire thing is going to cancel out with this thing. The two 2's are going to cancel out, and what you have is k is equal to f over h. So pretty much a nasty looking equation, but it kind of works out real nice at the end. Excellence is what you get for getting f over h. The function of f of g or h, potentially k as a function of f, g, or an h. Okay, so that's going to get you a merit up to here. Correct expressions for all four roots obtained and then achieved for getting all four of these roots. Yeah, so if getting four of those roots actually gets you an achieved. Excellence is all the way at the bottom there. Yeah, so it's a bit of an awkward question, but it does work out quite nicely in the end. But yeah, that's pretty much question 2, guys. All right, guys, let's get started with the last question here. So question 3a, part 1, we just got to take square root of 49, which happens to be 7, and then square root of y to the power of 36. Now, this is a very cheeky trick that people do. Remember that when you take square root of a power, you're actually halving it. And you know, most of the time I see people who got 36, they just put it straight up as 6 and get this answer incorrect. So this is actually worth an achieved. And then we go to the next question. We've got 2x 2 to the power of x equals to 2022. You can take logs and kind of work it out. Otherwise, you could also go into equation mode and go straight into solver, and you can just put it in there straight away. So 2 to the power of x equals to 2022, and press solve. Oh, that is not good. Must have done something. What do I do here? Can't solve. This is new. Wait, that was a bit weird, but like all I did was I just reset the calculator, and seems to be working quite all right now. So 10.98 is the answer for that one. So you can actually put that straight in the calculator. Otherwise, if you want to do it by logs, then what you would do is take logs of both sides. So you've got log 2x equals log 2022. Bring the x to the front. So you've got x log 2 equals log 2022, and then x is equal to log 2022 divided by log 2. Let's see if that works. You know, I've not seen that error at all, unless I typed in something wrong. I need to actually go back and watch the video again just to see where I made that mistake. But that's all right. 10.98 is the answer you're looking for. That gets you an achieved. And then we go on to the next question here. So the next question is write it as a single log. So what we're going to do is we're going to get rid of the 2 first. And so we're going to rewrite this as log of 3a plus log of a over 6 squared. And then we could write this as, what do we do? 3a, 36, 12, yeah. So we've got log of 3a plus log of a squared over 36, and then we multiply each other. So we're going to get 3a times a squared over 36. So what you end up with, log of 3a cubed over 36, and 3 and 36, you can get rid of the 3, which means a cubed over 12. Grades wise, this question is worth a merit. Fractional correctly simplified, but otherwise correct. An achieved is, let's say you make a mistake here, but you kind of like keep carrying on. You could get potentially an achieved for that question. Okay, let's go to the next one. So what do we got? Consider the equation where a and c are constants, and then make x the subject. All right, so we got to make x the subject, right? Now, the first thing I'm gonna kind of do is it's actually got log to the base 2. And because it has log to the base 2, I can rewrite this as x minus a divided by x plus a equals to c. Because remember that when you have something like log, I don't know, p minus log q, this is the same thing as saying log p divided by q. So that's all I'm doing there. But I'm keeping that base 2 there. Now the next step is that because it's base 2, I can get rid of the log by rewriting this as x minus a over x plus a equals 2 to the power of c. All right, once that's done, now it's just a matter of like cross multiplying and rearranging. So I've got x minus a equals 2 to the power of c multiplied by x plus a. So I'm going to get x minus a equals 2 to the power of c times x plus a times 2 to the power of c. Should really put this x in front because it kind of feels weird with the x after the c. All right, so the next step I'm going to be doing is I'm going to bring x to c to the left hand side, which means it'll become x minus x to the power x times 2 to the power of c. I'm going to get rid of the a to the other side, which becomes plus a. A plus a to c, yeah, that's all looking good. And I'm going to take x as a common factor, so I'm going to get 1 minus 2 to the power of c equals a as a common factor, which means I'm going to get 2c plus 1. Of course, I could rewrite this as 1 plus 2c just to make it nice and pretty, as it is in the question. And my final step is x equals to a 1 plus 2c divided by 1 minus 2c. Basically, guys, this question is actually worth an excellence question. Now, I have to say this, right? It's a very nice excellence question because, I mean, like, if you've been watching some of my tutorials, it's kind of hard because you probably haven't watched some of them. But, like, yeah, look, there will be some playlists popping up at the end. Have a look at them, and I've done these types of questions before where we do these live stream tutorials and like people have just kind of done these questions, and if you got this question correct, yeah, good job, man, because it's pretty, so it's a nice question. Grades. Excellence there. Correct exponential equation obtained, line 3. Line 3 is where for us? Line 3. Line 1, 2, 3. I would say probably here is where you're looking at a merit, and then here is where you're getting an achieved. Yeah, so pretty much this question here is probably the nice excellence question that I talked about, because the next question I guarantee it's not. It's just one of those weird questions where you have to write a lot. So have a look through the question, and I'll kind of kick off with this. Hopefully you had a chance to pause it. Okay, so basically what this says is that, you know, this equation has got only one possible for some values of a and c. Describe which values of a and c will make the equation possible to solve. Okay, so it's, let me, man, this is one of these weird questions, but like there's like a few situations that could happen, and you got to talk about these 3 situations. So the first one is fairly obvious, right? The first one is right here. Notice how like it says 1 minus 2c. You can't actually have c as equal to 0. So this is situation 1. C can't actually be equal to 0, because if c equals to 0, x becomes, so you can kind of say if c equals to 0, x is actually undefined. All right, that's the first kind of constraint that we can kind of pick up. Now the second constraint is if a equals to 0, then x becomes 0. How do I know that? Because have a look at this. If a is equal to 0, then x is equal to 0. Now if x and a is equal to 0, you can't actually take log of 0. So again, you kind of say if a equals 0, then x equals 0. What can we say? Logs is undefined. Okay, because you can't actually figure out log of 0. So if I go into my calculator, what do I mean by that? If I go log of 0, doesn't exist. All right. So in this case, notice how I've connected up with that. So if c is equal to 0, x is undefined, because you're going to get 1 minus 1 and 0 is in the denominator. That's why situation 1, it doesn't actually work out. And the last situation is this. Both of these things here, the x minus a, x plus a, it cannot be a negative number, or nor can it be 0, because the moment it's equal to 0, the whole equation doesn't actually work. So you have to kind of say that x minus a is greater than 0, and x plus a has also got to be greater than 0 to get a solution. So weirdly enough, guys, that's pretty much it for this question, because they kind of ask these situations and then that's where they leave it at. So if you go to the answers, kind of talks about the same things, but I've just kind of simplified it. One constraint identified gets you a merit. 2 reasons gets you an excellence. We've just given you, well, I kind of talked to you guys about 3 reasons there. So excellence for 2, and then merit for 1 of these reasons. Pretty short second part of the short question 3, because I mean, I know it had 5 questions, but then especially that last question, it just kind of like fell right through. Anyway, guys, that's basically it for this particular paper. My advice is, like, try and watch all the live stream tutorials that I've done, work through the skills, practice those past exam papers. You guys will get given access to like Cohere, like SynCos, and different types of papers. Make sure you attempt all of those, and then that should pretty much get you ready for this exam in 2023. Stay tuned. At some point I will be running live streams again. So yeah, but most important thing, don't leave a question empty in this paper. All right, it's super important. Just write. Yeah, don't leave it empty. But again, if you have any other questions, drop it in the comments below. Yeah, that's about it. Hey guys, that is basically it for this video. As always, don't forget to like this video, share this video, and of course subscribe to keep up with the latest content. There should be some playlists popping up. Check them out. Great revision material. And as always, thank you for watching.